Hello. In this video, we're going to look at an application. How long will it take an investment to double at 4.2% interest if the interest is compounded semi-annually? Okay, so this is actually just a compound interest question. So we have A, P, R, N, and T. A in this case, A and P, we'll come back to those in a second. R, we know for sure from right here is 4.2%. So that gives us 0.042 as a decimal. Compounded semi-annually. Now that compounded semi-annually, well, how many times does something semi-annual happen? Well, semi-annual happens twice a year. What we're trying to figure out is time. We don't really know when this is going to, or how long this is going to take. And it wants an investment to double. And here's the thing. You can use anything you want for P, but I recommend 1 because you want the future value to be double whatever your present value is. So I would recommend putting 2 in for A. And then using the formula, A equals P times 1 plus R over N to the N times T. Notice that we then just plug in A to be 2, P to be 1, R and N, and just keep the T as T. So plug everything in, we get 2 is equal to 1, or just not really writing it, 1 plus 0.042 over 2, all to the 2t. And then we can just solve for t. Notice that 1 plus 0.042 over 2, if you type that in, that's going to just give you 1.021. So really this equation is just 2 equals 1.021 to the 2t power. In order to solve this, we want to use a logarithm. So let's go ahead and convert this into a logarithm. And notice that our variable is in the exponent. So let's go ahead and get that one by itself. So that makes that 2t is equal to log base, this entire 1.021 of 2. And then to get the t by itself, just divide by 2. So t equals log base 1.021 of 2 all over 2. And believe it or not, that's pretty much it. Let's go ahead and just round to the nearest decimal. And if you type this in, this is going to give you 16.7 years. So there you go. It would take 16.7 years for an investment to double at 4.2% compounded semi-annually. Now, this is actually very helpful for us because this is very much related to doubling, or how long it takes for prices to double in an economy. Because in an economy, we have inflation, right? So what I want to do is I want to talk about inflation as it is right now in the US. So right now, as I'm recording this, it is currently October 7th, 2020. So I'm going to type into Google US inflation 2020. And then currently, our inflation in an annualized rate is 0.62%. Now, what that tells me is that the R equals 0.62%. And what I want to know is how long will it take for prices to double if this is the interest rate? We're going to assume N equals 1. And of course, A is 2, P is 1, and I want to know what T is. So to do that, let's plug everything into the formula. That's going to give us 2 is equal to 1 plus 0.0062 all over 1, all to the 1 times t, or just t. Now notice what happens here is that we really just have this as 2 is equal to 1.0062 all to the tth power. And then we can just convert this into a logarithm, and that would be that. Now, notice that if we type this into the calculator, I actually don't know what this is. I'm doing this right now. So if we do log base 1.0062 of 2 and click enter, it tells us that it will take 112.1 years for prices to double. That's a very long time, but this is a very small interest rate. It's a very low interest rate. I will tell you, generally speaking, this is a very huge anomaly in financial mathematics, in anything to do with finances, because 0.62%, it's happening because of all the craziness that's happening right now, all the COVID and all of the reduced economy. Everything is causing the inflation rate to go down. Now, whether that's good or not, I will allow people that are far more qualified than I am to actually answer that. But that's a very low interest rate. What I want to do is I want to now look at what happens if you have a very high interest rate. And I'm going to take Google and I'm just going to type in highest inflation rate in 2020 in the world. Okay, so Trading Economics has a nice one here. It looks like Venezuela currently has around 2,358%. It is the highest in the world right now. So 2,358% inflation rate. And again, everything else here is going to stay the same. I'm not going to rewrite that. But I do want you to understand something. That is a huge inflation rate. The very next inflation rate, the second highest inflation rate in the entire world, is Zimbabwe, and they have 761. So at this point, Venezuela is over 3 times the inflation rate of the next highest country. So let's see how that affects this. Plug everything in. That gives you 2 is equal to, well, I wanted to use red here. So 2 is equal to, parentheses, 1 plus. Now, with this one, just move the decimal 2 places to the left, makes that 23.58 over 1, all to the 1 times t, or just t. In other words, 2 is equal to 24.58 to the tth power. So it means that t is log base 2 of 24.58. So I'm going to take my calculator and type that in. So log base 2, no, sorry, the other way around. Log base 24.58 of 2. I'm not used to the largest number being at the bottom portion there. So 24.58 of 2. Good deal. And so this tells me that t is 0.2164 blah, 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 blah years. That's not very long. So let's expand this just a little bit. I'm going to take this and multiply by 12. I want to know how many months does this take? Well, this takes 2.59, so basically 2.6 months. So at 2,358%, it's going to take 2.6 months for prices to double. That is one of the reasons why Venezuela's economy is not fantastic, I will say, at the moment. And I'm not going to speculate as to why it's so high. That's probably going to deal more with politics than it does economics. And this is a math class. I don't really want to deal with politics. You can go read up on Venezuela on your own if you wish. I'm not going to discuss it any further. But what I do want to talk about is notice what's happening here. 0.62% takes 112.1 years. 2,358%, it takes 2.6 months, or 0.2164 years. Notice that when the inflation rate goes up, the amount of time it takes goes down. Okay, this is what we call an inverse relationship. So if the inflation rate goes down, the amount of time it takes goes up. So it's always one, as one goes up, the other goes down, and as one goes down, the other goes up. Fantastic. Well, I'm going to go ahead and end the video here in just a second, but notice something. I normally say that I'm going to see you in the next video, but I'm not going to, because this is the end of class. Congratulations. It took a lot of work to get here, and I hope you enjoyed it in some small fashion, and even more importantly, I hope you learned something. Alrighty, well, I believe I'm going to go ahead and end it here. Have fun.